All right. How many of you guys were at Spark Summit today? All right. And did you guys have a good time? Enjoy it? Yeah. All right. Very good. Very good. So yeah, I'm honored to be here. I'm invited by Alexi to talk about productionizing Spark and the Spark job server. Just a really quick note. The picture is where I live. I'm very excited to find that in the audience there's some folks that live really close to me. So I've been using Spark for a long time, since version 0.8, and also Cassandra for a long time, since 0.6 or so. And I have two main open source projects that I actively work on. One is the Spark job server we'll talk about tonight. There's another area of active research or fun for me, which is working on OLAP on Spark and Cassandra. If you're interested in that topic, feel free to talk to me afterwards as well. Be very happy to talk to you as well. And the Spark job server, we'll go into that in a little bit, but I co-created that with Kelvin Chu, who's also in the audience. Kelvin, you want to raise? Yeah, there you go. And Kelvin's at Uber and gave an excellent talk today as well. So the Spark community is alive and just really kicking it. So deploying Spark, we'll start here, because really there are so many choices. You have, do you deploy on Yarn, Mesos, Standalone? Do you go with one of the other hosted options? Do you go with the distribution? How should you deploy it? The funny thing is, when I was doing this talk, I found there was almost no material on the web or out there that kind of just does an intro and talks about Spark, production or operations overall. Like there's some talks you find on Yarn, and there's probably a talk by Mesosphere, but overall it's surprisingly little material. So this is more intended to get feet wet, thinking about overall what things to consider. Then we're going to talk a little bit about how to some tips for running Spark applications and things to watch out for that I found useful. And then we're going to talk about the job server. So first of all, sorry if the words are a little small, but just basic terminology for Spark. Every Spark application is called a driver program, or a driver, which is on the left side. And it creates what is called a Spark context. And all the operations that you do in Spark are driven by the Spark context. And the way it works is a Spark context works with a cluster manager. A cluster manager then represents whether it is Yarn or Mesos or other things. It manages workers. It spins them up, and it manages the communications. It feeds tasks to each worker. And each worker node has what is called executors. So it's called Spark context where there are one or more executors on each node. And the executor is actually what carries out the individual parallelized parts of your processing. Furthermore, there is a cache. Spark is known for in-memory processing. And on each executor is where most of the time the cache data or caching of intermediate operations lives. And what the task is, it seems obvious, but basically a Spark job is broken up to many, many, many tasks. And so this is just basic terminology. Is everyone OK with terminology? Pretty good? All right, awesome. The Spark documentation is really quite good. This picture is just taken from Spark. So let's talk about Yarn and Mesos and Standalone. There's a couple of interesting options. All of what are called cluster managers support some common features. All of them will allow you to run your Spark apps in what is called a cluster mode, which means that you can actually submit your applications and it will run on one of the workers in a cluster. And all of them support restarts of your application when it fails. At least the most recent versions of Spark do. The support of restarting the driver app was, I think, for standalone mode is relatively recent. I'm not sure how long Yarn has had it. Mesos has been able to restart stuff for a while through things like Marathon. And they all have different UI. Well, they all have UIs of some sort to expose the state. However, the UIs are different. Spark, the Spark driver actually always spins up an HTTP server where you can get the state of each Spark application. And that will tell you all of the tasks that are running. That is common to every environment. And then what happens is that there's a separate UI, which is the cluster UI. The cluster UI tells you what are the applications that are running. And this is different for each environment. So the Mesos UI looks different than the Yarn UI, which looks different than the standalone UI. So the Spark standalone mode. I said it was the easiest clustering mode to deploy. Although while I was writing this, I discovered some neat stuff that might change that. But the Spark standalone mode, sorry, I should step back and explain what it is in case you don't know. But basically, Spark standalone mode means that it runs without something like Yarn or Mesos. You have a master process. And the master process is responsible for allocating workers, right? And the way, let me see, what did I say? Right. So the way you package it is that you use this script called make distribution that creates a binary Spark distribution. Then you can ship that distribution to each of your workers. You pick, and then you would pick one of those nodes to act as master, and you would run the script called start master. And you would typically check that, thanks. Okay. You would typically check, the first thing that I usually do is I test it with Spark shell to make sure that it can connect to the master. It might fail and say that there are no workers, then you can start some workers, then the workers will attach, and you probably shouldn't even need to restart Spark shell. The workers, because in standalone mode, you can attach workers at will. So you can add an additional worker, it will attach, it will register with the master, and it will become available. However, your application, when it starts, you have to give it a certain number of CPU cores and memory. So that part is not dynamic. So what happens is that the workers, if you add additional workers, the master knows about them. If you start another application, then that application can take advantage of those new resources. Let's see, what else is here? So there is an X-ray mode for Spark masters, so that if this master goes away, another one lives, which is done through Zookeeper election. Now, the biggest difference between the standalone mode and something like a Yarn or Mesos is that the standalone mode means you have to dedicate the whole cluster to running Spark. You're assuming, Spark is going to assume that you're dedicating all of your CPU, all of your memory on each of those workers to Spark. And yes, it is rarely used in production, although actually at Ooyala, we actually did run some standalone mode in production. So it is possible, but since there are other better options now, let's talk about those other options. So Apache Mesos, this is a really brief introduction. It was started by Matthias himself in 2007 before he worked on Spark. I believe that Spark was actually Matthias' idea, like an idea of using Mesos. So Mesos was actually his research project, and Spark was an application to run on top of Mesos. What is very ironic is that since then, Mesos hasn't necessarily been the most emphasized cluster manager in Spark. But yeah, that's a very interesting history. Mesos is not designed just for running your big data or Hadoop workloads. It is designed to actually run all of your applications or your company. So an example is that, for example, our current company uses Mesos to deploy microservices. So you can deploy Docker containers on Mesos, and they have Mesos as multiple resource managers that can work with microservices and restart them. The most important one is called Marathon, but there are other ones out there. Twitter has one, name of which I forgot. Anyone remember? I don't quite remember what it is. But so Marathon will actually deploy your apps, and it will know how many instances there should be. If one fails, it will start up another one. It will also do DNS routing so that it can route HTTP requests that go to one endpoint to your services for you. And Mesos can also run non-JVM workloads because it uses a C++ libmesos.so library. So it can work with a lot of workloads like MPI. The downside of this is, of course, that you need to install libmesos and run JNI. However, I've heard from Mesosphere that they are working on an HTTP API so that you will no longer need to install libmesos, which would be pretty cool. It is heavily used at Twitter and Airbnb, and Mesosphere is doing a lot of cool stuff. At this point, I'll call out the Mesosphere DCOS, which, if you don't know, how many people have heard of Mesosphere DCOS? You know, it's very, very exciting. It will let you deploy Spark by typing in DCOS package install Spark. Then you install Cassandra, you just do DCOS package install Cassandra. So I'm just waiting to check this out. This sounds very, very cool. A little bit about Mesos versus Yarn. Yarn is a resource manager and a scheduler. Mesos is a two-level resource manager, which basically lets resource managers schedule stuff themselves. So this seems like it's a very important distinction. Basically, you can, maybe one way to explain is that there's a project where you can run Yarn within Mesos, and the way that works is that Yarn will let Mesos delegate or offer resources. If you run Yarn normally in Hadoop, the Yarn will also know about all the resources. If you run it on Mesos, basically Mesos at the top level knows about all the resources, and it lets other schedulers then receive. Basically, Mesos will offer resources to different schedulers. And the schedulers will then take those offers and decide how it wants to schedule them. So in this case, Mesos will offer resources to, say, Yarn. It can also offer resources to, say, Marathon. And that way, Yarn and Marathon can cooperate and manage your entire data center and offer some resources to Yarn for running big data workloads, and then offer some resources to Marathon for running your Docker microservices. You can also write your own schedulers within Mesos. I guess this is probably obvious, but if you are a Hadoop shop, there is obviously a strong incentive to use Yarn because you're probably upgrading your cluster to use Hadoop 2.x. If you're starting out, I would recommend that you go with Mesos because you can run your whole infrastructure for your company on Mesos. Mesos offers two ways of, Spark runs Mesos jobs in two modes, which is very interesting. One is called coarse-grained and one is called fine-grained. What coarse-grained does is it's very similar to the Spark standalone mode. At the beginning of your Spark application, you give it a fixed number of resources, and Mesos will give you a fixed number of workers. And that number stays fixed for the duration of your application. Example, if you want to run a bunch of quick, fast queries, each of those might consist of a few tasks, and then you might run another query that has a few tasks. You don't want to be allocating new workers every time you get a new task. So in that case, having fixed resources is probably a good thing. Fine-grained, which is actually the default, means that you have dynamic worker allocation. So with every task, it will actually go back to Mesos and ask for resources. This means that as your job is running, the size of the worker pool will change, but it also means that every task has a certain startup latency because it has to wait for Mesos to allocate resources, workers. But it is very interesting, and I think we've tried both. What about Datastax? Just a raise of hands. How many people are running Spark on Cassandra? A few folks. Cool. I just wanted to mention this. Datastax has their own implementation of Spark on Cassandra, which is very interesting. It packages Cassandra, Hadoop, and Spark all in one. So it's a different resource manager. What they do is they use Cassandra Gossip as an actually mechanism for Spark masters. So it's like Standalone, but with Cassandra coordinating the failover instead of Zookeeper. It's pretty interesting. If you use Datastax DSE, you can use the CFS, which is Datastax implementation of HDFS on Cassandra, and you can use that to write your files. Or you can just write data to Cassandra. I also mentioned Tachyon here, which is pretty interesting option to think about. It doesn't just apply to Cassandra, it applies to everyone. But if you are, say, not using Datastax Enterprise, you could use Tachyon as a caching layer between Spark and Cassandra, and then that would work with things like Mesosphere, where you, at least as I understand it right now, you can't really guarantee that you can collocate your Spark and Cassandra clusters. You guys might have heard, so what about hosted Spark, right? So you guys might have heard the announcement today that Amazon is making Spark a first-class citizen for EMR, which is pretty cool. I'm not sure what the difference is exactly, to be honest, but before that, they were running Spark on top of Hadoop 2.0/Yarn, and I think some people complain about various problems configuring it. So hopefully this will be much easier now and would be a pretty compelling option. Google Compute Engine apparently has a click to deploy Hadoop plus Spark. Anybody run on Google Compute Engine here? No, okay. There's obviously Databricks. I guess it's no longer Databricks Cloud, it's just Databricks. So strike that. And I suspect that many more are coming. Like if you went to the summit, you'd notice that there were various vendors that were offering hosted Spark. Well, I know of at least one. So this will be a very interesting space to watch. Anybody care to share other ones that they know of, like other hosted solutions? Okay.
Azure.
Hmm?
Maybe Azure.
Oh yeah, I guess Azure might. Yeah, Azure is probably doing that. Yeah.
Blue Data claims it has hosted Spark.
Oh, who's that?
Blue Data.
Oh, Blue Data. Okay, Blue Data for. I think that's the vendor that I saw. Yeah, that has hosted Spark. So this will be a very interesting space to watch. Just an interesting note about the different environments. Every environment has a different way of starting Spark. DSE has DSE Spark or DSE Spark Summit. EMR has its own command. DCOS has their own command for writing applications. So this will be a very interesting space. How do you, unify all these different commands? Maybe you can use a REST service. But we're not quite there yet. So a few tips on configuring Spark. Make sure you build it for the right Hadoop version, if that matters. Building is kind of a big chore whenever you need to install Spark today. I think there are binary versions of, if you get Spark through distribution, then obviously this is taken care of for you. But for me, I've always had to build Spark. And you can also build it for different Scala versions, which is something to note. They offer for both Spark 2.10 and, Scala 2.10 and 2.11. The Spark Job Server also lets you build for 2.10 and 2.11. Make sure your Scala versions match. Jars, our favorite topic. Basically, dependency management on JVM is a royal pain. There's really no other way to put it. Every distro has slightly different things. If you run CDH, how many people here run CDH Spark? Few. You have to be aware that CDH before 5.4 shipped with a different version of Akka from what the regular Spark distribution did. That causes pain if you use it with Akka and Spark, which the job server does, for example. I highly recommend leaving out Hive if you don't need it, because Hive brings in like about double the number of dependencies. There is a UI that I'll show you later. There's a tab which is really convenient for checking your dependencies and where they came from. I'll mention this again later, but Spark Summit has a really useful flag called Datastax jar or Datastax packages, which forwards your jars to each worker. However, you might want to actually use Spark Classpath and push your jars to each node. The reason is because you might not, especially if you're a big jar, you might not want Spark to download from your driver to n nodes, however big n is, every time you start a new job. And the behavior, at least as of 1.3.0, is that when you start a context, that's not when Spark downloads the jars. The Spark downloads the jars when you start your first job. So that whatever the first job is going to take a hit that first time. So some useful config options. If you do a lot of network I/O or shuffles, you'll probably want to use the Creo serializer. The problem with using Creo is that you have to register every custom class that your application needs. Spark does include all of the common Java collections, Scala collections, and other common Scala classes. But you do have to do some work. But it's pretty much always worth it if you need performance. The default parallelism for controlling the number of shuffle reduce tasks. This is useful for certain times when, like, a lot of people don't use the Java Scala DSL, right? They use other frameworks on top. So that's a way of controlling there's a default parallelism level that gets used for the reduce tasks, which you might want to tweak. This is a schedule. Let me see. The memory fraction and the storage fraction is important if you want to cache your RDDs. If you have a storage memory fraction of 0.6, and you have, let's say, I can't really do math. Let's say you have 10 gigs of heap, right? So then that means that Spark will use at most 6 gigs to cache your RDDs, and you have 4 gigs left over for everything else, including processing and, yeah. If you run long-running contexts, you will care about Spark Cleaner TTL, which tells you how long Spark is going to wait until it cleans up RDDs that are cached. This is usually set for streaming jobs, for example, to make sure that there aren't too many outstanding RDDs. Let's see what else. There's a max failures. The scheduler mode won't be relevant for most people, but it will be relevant for things like the job server. I'll mention this again later, but it enables you to do some level of parallelism for tasks. If you run Spark SQL, you'll probably want to set Spark SQL shuffle partitions. Unfortunately, it is set manually. I believe that they're working on some kind of some automatic way of figuring out number of partitions. But for now, you need to set ahead of time how many shuffle partitions that you need. Let's see, do I have something else for this? Oh, I guess not. I was going to say, like, I think my rule of thumb is to, maybe that's for something else. Usually for stuff like that, it's like that for the shuffles. You know what? No, I think that's something else. Okay, never mind. There's various policies for controlling the number of temp files. If you're running in standalone mode, you might notice that your disk will fill up. And this is because Spark, by default, will not clean up your temp files. Half the things I talk about are just things I know about because I either contributed them or commented them or that kind of stuff. Although it's pretty easy to run a cron job yourself, but it's good to be able to set a flag for Spark to clean it up. Running Spark applications. So there's different ways to run your apps in the cluster. You definitely want to avoid running jobs on your local machine. We'll talk about how the job server helps that. And there is, if you run, wait a minute, sorry. So yeah, so the deploy mode cluster means that it's running your application in the cluster itself as opposed to, say, on your laptop or wherever you submit it from. I'll just note that if you want, so this is an important feature, if you want your jobs to restart when it fails, you can use, there's different ways, well, every different way of running Spark has its own way of doing this. You can do deploy mode cluster. For standalone mode, you need a supervised flag for it to work. For Mesos, you will get that automatically if you use Marathon. One thing that is good to note for these restarts is checkpointing. Because Spark, by default, it will recompute your entire chain of computations. And you can use checkpointing to help shortcut that. Let's see. Oops. So, right. So speeding up application startup. I think I mentioned most of this already. But if you want to avoid the packages option if you want your jobs to start quickly, because otherwise it will use HTTP broadcasts to basically, it will download the jars from your driver's HTTP server, which might take a while. If you want really fast Spark jobs, we can talk about the job server and how that enables that use case in just a minute. You can get metrics. So when you productionize Spark, metrics is probably, you probably care a lot about metrics. So there's a built-in metric system that has source and sinks, and it's all written based on the CodaHail or Yammer metrics library. So the sinks are the same as what CodaHail offers, so graphite, ganglia, et cetera, et cetera. And there is a JSON metrics thing as well. So there's a metrics.properties file that you can configure to configure the sinks and sources. I will also just, you guys can click on this link. Well, I won't click on it now, but for ways that examples of visualizing. Basically, there's people that build, say, Grafana dashboards where you do visualize the built-in Spark metrics, which is pretty cool. And my old colleague at Ooyala also built an interesting small library on top of Spark accumulators that ties that into. So how many people know what Spark accumulators are? Few people. So let me explain. So basically, let's say, so in Hadoop, you had counters. So Spark doesn't have counters, so what do you do, right? So Spark has something else called accumulators, which is where on each task, you can, if you have an accumulator, then you can add some number to it. And then Spark will automatically get all those counters and merge them at the driver. And you end up with the sum from your job. So that's how you implement counters in Spark. There's a library there that, you get the slides later. But that would tie Spark accumulators in with the Spark metric system. That way you can use accumulators, and the metrics from your application will then get fed to all of your sinks, such as graphite, et cetera. So that might be a good way for you to get application metrics out. I don't know if there's anybody aware of other ways of getting metrics out from Spark applications, but. You want to watch how RDDs are cached. There's a really useful storage UI tab that tells you all of your cached RDDs and where they're being stored. If you see this size on disk is non-zero and the size in memory is 0, that would probably tell you why your cache queries are running slowly. If your jobs are stuck, there's an executors pane of your Spark job, and that now has a thread dump link, which is pretty useful. You can click on that and get a thread dump, assuming that the UI is responsive. Finally, this is what I was talking about earlier. There's actually a very useful, under the environment tab, there's a whole section for Classpath entries. The ones that say added by user are the ones that are added with the -- packages option. The reason why the packages option is useful, by the way, is because it will actually pull down dependencies from Maven. So for example, let's say I run Cassandra, I want this Cassandra Spark connector, I can add the Maven coordinates, and it will download that one and all the dependencies, which is super convenient. But again, it will, don't do this in production, because in production, you don't want like your Spark thing to be downloading from Maven, So, yep. So the Spark job server, we come to why. So just a really brief history, or sorry, an overview of what the job server is. It is basically a REST API for operating Spark jobs and running your Spark cluster. So you can submit jobs to Spark through the job server. You can see their status, and you can manage Spark applications. One particular use case, one particular use case that it's good at is for sharing. Let's say that you want to share RDDs. And so in regular Spark, each executable, each application, its own entity. Spark Job Server creates a separate abstraction called a job. And a job is actually different than a Spark drive or application. The notion is that you can actually run multiple jobs within the same Spark context or driver. And that lets you do a lot of neat things, such as I can have different jobs be low latency queries, or I can basically modularize my Spark applications. Instead of having one giant application or driver, I can create separate components. I can test them independently. So I think it facilitates a better way of developing Spark apps. It will also save all of your jars and your job history and configurations to a database. And so basically you can go back and you can revisit history and things like that. And it has an async and a sync API. It takes your job results and converts it to JSON. So again, you can interact with it from virtually any language. And it has support for Spark SQL, for Hive context. And basically, it can be extended to support virtually any type of Spark context. And it is open source. You can find it at the URL, and you can also find it at Spark packages. So just a really brief history. We created, Kevin and I created together at Ooyala at the beginning of 2013 when it was just Spark 0.8. This was before there was Spark Summit. This was before there was a Spark history server and all kinds of stuff. And the reason why we needed it is because Spark, at that time, the way that you ran Spark applications was that you just ran the application on whatever, on your local box or on typically in some cluster. And we really wanted to make this easy. Like for us, we envisioned Spark as a service that multiple teams can run. We didn't want to create, what was happening was we would have to set up batch inboxes on a cluster, like say one per team or one per person or something, and to let them run their Spark applications. And that wasn't really a scalable way or a secure way to let teams use Spark, right? So we wanted to have people focus on writing the jobs and not on deploying them and tracking job status and this kind of thing. So we wanted to provide a common infrastructure to operate Spark as a service by developers that want to run Spark jobs. And finally, we had a pretty polyglot technology stack. We have Ruby, we had Go, so this is another reason why we wanted it. So I'll go over an example workflow. This is for a Scala project that you would add a dependency on the API. And you would basically create an assembly jar, which excludes Spark and other dependencies. And then you would upload it. So a really quick example of a job flow is that basically you have to implement an interface. There's two methods in interface. It's relatively simple. One is run job, which does exactly what it says it does. You are passed a Spark context, and that's a very important difference. You don't create the context in your app. It is created for you. And you're passed a config, which is basically passed in when you do a post. And there's a validate method. The reason why there's a validate method is because this is following HTTP semantics. When your input is not valid, you don't want to just run the job and fail with a 500. You want to return a 40x code to indicate that there's a problem in the response. So this is to facilitate a standard RESTful API. And it also gives you a chance to fail early from your job and not get just some random unhelpful exception. Notice that I can actually specify a reason why the configuration that I input is not valid. Right? And the run job itself does exactly what you would expect. I can do the standard Spark commands to do transformations, and the response that the result of that function would be then automatically serialized and returned to the user. So what is different? So I said this, the job does not create a Spark context, the job server does. And this allows you to decide exactly how you want to run the job. Like you can pre-create a context with certain parameters, and then you can run the job. So it separates out the creation of the Spark context and all the things with the actual job functionality. And it allows for modular Spark development. Like an example is, let's say I'm working with Spark SQL on Cassandra or some other source. I can have one job that is just for loading the tables, and that can be tested independently. Then I can have one job that is just for querying them, and again, that can be tested independently. And I can have one job to do diagnostics. For example, I can load it, it can figure out what tables are cached, and tell me other things, and report debugging information. This is a little hard to see, but the top, so you have one curl command that would upload the jar to the job server, and you specify an application name, which in this case I call demo. The job server tracks different versions of the jar. So in the next curl, I'm actually giving an input. In this case, it is inline in the curl, but more typically it would be referring to or whatever REST API you use. It could be a JSON blob, or it could be in the type-safe configuration format, HOCON. JSON is completely fine. And in this case, my job jar is called word count example. And I'm just going to take that sentence and count up the words, and you can see that I get this result, which is a JSON map of the words in our counts. I can very easily retrieve the job status. Let's say I want the last two jobs that ran, and I can see how long they ran and what what job was running and in what context and what happened. So if there was an error, you would see, instead of finish, you would see error and what the exception was. And since then, we've also added logging or saving of the config. So basically, every job input that is passed in is also saved. So you can go back and usually trace what was the input that caused the error. So very quickly, we go into fast query jobs. The goal of this was to have Spark jobs that can run very quickly in a second time frame and answer queries on shared RDD. So this is using Spark as a query engine, as a REST query engine. The query params are passed in as the job config, as JSON. And we wanted to minimize the, so the reason why we don't just submit a regular Spark app is because we want this to be low latency. When you start a Spark application driver, it typically takes at least 5 seconds just for it to spin up all of the threads and the HTTP server and the file server and all the other things that Spark needs. So starting a new application is relatively heavyweight, and that's not counting all the time that you typically run into production. Mesos or Yarn would need to allocate all of your worker processes. Right? So this way, we can have individual logical jobs that are separated from the application, and they can run very quickly. So the way that this works is that we have a the REST job server. The first step would be we create a context, a Spark context. And so this creates a context which spins up the executors. Next, we can run some job that will load some data. So this might, for example, say get the data from Cassandra or elsewhere, and it would cache that data as cache RDDs. And the cache RDDs stay persistent in the Spark context after the logical job returns. At which point I can run a query job, which loads tasks that basically inquire into the saved RDDs, cached RDDs, and returns results. And I can do that again and again. The job server provides a functionality called named RDDs, where you can name what RDDs to save. This is pretty important because if you don't name them, Spark only gives you an API for a numeric ID. And so it's fairly difficult to figure out what RDDs have been cached. So it gives you a way to namespace your saved RDDs. And it is also designed to be thread safe so that you can run concurrent logical jobs or tasks. Let me skip this a little bit. So here's an example of a Spark SQL or Hive query server. Again, so I start a context based on SQL context. Notice that there's a factory. So basically, you can implement a factory to start up any kind of context you want, whether it be the built-in Spark ones, or you can create, for example, a custom Spark context type that holds some business-specific data. And then you can interact with that in your job. Then I would run a job for loading and caching tables in the data frames. And then I would supply a query, and the query could be SQL. There actually is a built-in SQL query job in the job server. And this was a use case that we just got, which is pretty interesting. Someone wanted to combine streaming and Spark SQL. So the way it works is we create a special type of context called a Spark SQL streaming context. This doesn't come in a job server, but I'll just show you the code is actually fairly small. So let's say that you have data coming in from Kafka, and you would have a streaming job that is running all the time. The streaming job would create data frames, and those data frames would be saved as the SQL context tables. Then you can run a SQL query job on top, which is querying those saved data frames. So pretty neat. The code for doing this is pretty lightweight. I define a trait Spark SQL streaming job, and I say that those kind of jobs need to be run under a SQL streaming context. The SQL streaming context is basically a wrapper around Spark context that starts up both a streaming context and a SQL context. So it's pretty self-explanatory. Jobs would then take in a SQL streaming context and have access to both the streaming parts and the SQL context. This is a little hard to see, so, but basically there's a SQL streaming context factory which knows how to create a SQL streaming context and take in configuration parameters. An example here is, this actually came from someone that uses a job server, which is pretty neat. But you would pull out the batch interval for Spark streaming from the config. Right? And then this would be used to initialize it. So that way you can do a REST call that initializes this kind of context with your batch interval. And it would know how to stop it and start it, et cetera. So just really quickly, the Spark job server uses a metadata store to store all the statuses and configs and everything else. Right now, it is defaults to an H2 database. You can configure it to point at any JDBC URL. And multiple job servers can share, and actually it's recommended to share the same database for HA. That way you can share jars and everything else, right? It also comes with scripts for deploying, as well as routes for getting metrics out. There's some challenges. I think that originally, basically, we deal with a lot of Classpath stuff and dynamic loading of jars because it has to load jobs as jars. So that's an additional challenge that we had. Also, when we started this in the early days of Spark, there was no restriction on running multiple Spark contexts within the same JVM, but now there is. So you need to set the special flag, allow multiple contexts equals true. This is a short-term solution, though, so the long-term solution is that we're going to fork off a separate JVM per context. And finally, some interesting future work that is coming up. Probably the most requested things are true HA operation, which means, I'll explain what that means in a second, and things like user permissions. You obviously don't want to allow anyone to delete jobs or that kind of thing. So that will be pretty interesting. We'll be adding that pending time and everything else. Just a really quick some slides on what HA means. An example of what I mean by the true HA is, for example, you can have, let's say you have 2 job servers and 1 active Spark context that's running. If one of the job servers dies, then your load balancer would reroute the request to job server 2. And because they share a database, and because the job server 2 knows about what's going on through gossip, it would know that it can then find out status from the active job. So it would keep that connection. The connection to the context would fail over to the job server so that it doesn't matter which one you ask. They would all know, they would all have consistent state. So this is interesting. Even more interesting is we could potentially have HA and hot failover for jobs themselves. This is a little bit of this is just a design, so it's welcome to comment. But imagine that you have an active job running. This is producing some state, it's checkpointing files to HDFS. Right now what happens is if it fails, Yarn or Mesos could restart it, then it's going to load that checkpoint file if you've enabled it. But imagine if we could have some kind of hot failover, right? So that you have a standby Spark driver that is actually running, and it is able to continuously reload state and update the checkpointing. That way, when it fails, then that way it's no longer just a restart, but the job server can enable a hot failover of Spark jobs where there is very little downtime, close to none, because the state, the expensive part, which is restoring application state, has already been done. Obviously, this won't work for all applications, but welcome to hear your feedback. I think it would be pretty cool. And would like to thank everyone for the contributions. We've gotten a lot of community contributions, which is really awesome. And we definitely welcome more contributions. I'll skip this part really quickly, but there are a lot of documentation for how the architecture works. Thank you very much. There are a few, yeah.
Can you mention them?
Sorry?
Can you mention them?
I think there are some, I think there's at least one in the audience, so you can talk to. How's that? Hmm?
Let's do that.
Yeah.
How reliability is the full value
Sorry, I can't hear your question.
So when a task failure happens, how reliable is the value of an accumulator?
Just repeat the question.
Sorry, so you said how reliable when a task failure happens, right?
How reliable is the value of an accumulator?
How reliable is the value of an accumulator?
Yeah. When tasks fail, I'm guessing the accumulator gets updated.
Yeah.
During that task, when the task is in it's retracked. Why that the value might not be reliable.
Yeah, I'm not really sure. I think that's a good point, because I think the updates get sent to the driver. You're talking about if just not the driver, but an individual executor task fails, and I'm not sure that Spark knows how to roll that state back, but yeah, that's a good question. Yeah.
For the people watching, could you just go back to the architecture slides?
Oh, sure.
Just for you don't have to talk about it.
Oh, okay, all right, sure, no problem. Yeah, is that good? Yeah. Okay, architecture, 1, 2, 3.
Well, that's some good music to this.
Yeah, right, that sounds good, All right, there we go. Thanks. Yeah, I'm available for questions afterwards too. So, yeah,
Your slides
thanks.
be available later?
Yeah, they'll definitely be available. Yeah.
Please, yeah.
Yeah. All right, thanks very much. We'll welcome the next speaker.